In an input storage account container, you have a folder for each month number of a year. Each of these folders contains a corresponding text file summarizing the sales for that month. You need to copy only these text files to an output container while retaining the file names as shown below. To perform this copy operation, you author a data factory pipeline whose JSON is given below. How should you complete the script? To answer, select the appropriate values for the correct target. To achieve the desired output, we can either run the copy activity once with flatten hierarchy copy behavior or use a for each activity that defines a repeating control flow with a copy activity. Since the given JSON uses two activities, there is some indication that the latter solution could be a better fit and that the copy or the for each activity could go into either box A or box B. In the explanations for question 2, I will explain why the former solution is not correct for this scenario. While using for each with a copy activity, the usual order in the UI is to first create a for each activity which iterates through an input array passed from the pipeline. And within the activities section of the for each activity, add a copy activity. So for each item in the parameter array, which typically are folder names from the source container, there is a copy activity that copies the data from one storage account container to another. In the given JSON too, we can observe a similar order of these two activities. In fact, without any of this analysis, we can confidently say that the copy activity would go into box B as activity 02 as references to sync and the copy behavior property. Consequently, the for each activity would go into box A as it references a list of items passed from the pipeline parameter to iterate through. So question 1 is box B. If there are multiple files and folders for a copy activity, the preserve hierarchy copy behavior will preserve the same hierarchy in the target container. The flatten hierarchy will copy all files from the source container into the first level of the target container. Going back to the beginning of this discussion, using a single copy activity with flatten hierarchy copy behavior can also achieve the desired output. But as you can observe, the flatten hierarchy copy behavior will not retain the original names and will have auto-generated names which we don't require. And the merge files will merge all files from the source container into one single file. However, since the copy activity is run inside a for each loop, each copy activity picks up only one text file, sales for a month, from the source folder. So irrespective of using either preserve hierarchy or flatten hierarchy or merge files, the output of each copy activity will be the same, copying a single file for that month. As discussed earlier, the flatten hierarchy will always produce auto-generated file names. Since we need to retain the same file names in the target, choose preserve hierarchy as the copy behavior. Question 2 is preserve hierarchy. Option B is the correct answer. You have a data factory pipeline run by a tumbling window trigger every 5 minutes. You need to ensure that the pipeline will run only if the previous two runs are successful. How would you configure the offset and window size for the trigger? In addition to configuring dependent pipelines, tumbling window triggers also enable you to configure self-dependent pipelines. That is, you can ensure that a pipeline is triggered only after its previous run is successful. To establish self-dependency, select the same trigger that triggers the pipeline while adding a dependency. To configure either self-dependency or dependency on another pipeline, we specify two values in a timestamp format: offset and window size. Let's understand these two values. Consider the offset as the starting point on the dependent window. A positive offset shifts the starting point to a future window. A negative offset shifts the starting point to a past window. Since we need to create self-dependency on the earlier runs of the same pipeline, we have to use only a negative offset. In fact, if you do not include a negative sign for the offset value while configuring a self-dependent trigger, Data Factory displays this error message. Options C and D are incorrect. Since we need to ensure the pipeline will run only if the previous two pipeline runs are successful, we need to offset two windows or shift back 10 minutes. Consider the window size as the duration of the window the trigger depends on. Since the trigger should run the pipeline only if the previous two runs are successful, the window size should be 10 minutes. Option A is incorrect and option B is the correct answer. Let's verify this using the Azure Data Factory Studio. I added a wait activity to avoid errors as we cannot publish a pipeline without any activity. I already set up the trigger with the correct offset and window size per the requirement. In the pipeline, I define two parameters, pstart and pend. Further, I pass the system variables supported by the tumbling window trigger as parameter values while triggering the pipeline. After the pipeline is published, go to the monitoring section to check if the pipeline runs are successful. Now, to simulate pipeline failure, I add a fail activity to the pipeline. After publishing the pipeline again, you can see that the next pipeline run fails. However, this pipeline was still executed as the previous two pipeline runs were successful. As the pipeline run failed, the trigger will not execute the next window as we had created a self-dependent trigger that requires the previous two windows to be successful. Your Azure Data Factory pipeline must run every 5 minutes with a delay of 1 minute. If a pipeline run fails, it must be retried thrice at the most with a 30-second interval. Which of the following triggers would you use to trigger the pipeline? You can create four types of triggers to run your data factory pipeline: schedule trigger, a tumbling window trigger, storage events trigger, and custom events trigger. Of these, only the schedule and the tumbling window trigger can run the pipeline on a schedule, i.e., every 5 minutes. Options B and D are incorrect. Of the remaining two triggers, you can delay the pipeline execution using only the tumbling window trigger. Option A is incorrect. As shown in the tumbling window trigger, we set the recurrence to every 5 minutes and include the delay as 1 minute in a timestamp format. Beginning from the start date and time, which is 6 a.m. UTC, the pipeline will be repeatedly triggered at 5-minute intervals. For the pipeline, I define two parameters, p start and p end. I pass the system variables supported by the tumbling window trigger as parameter values while triggering the pipeline. After the pipeline is published, go to the monitoring section. Since we included a 1-minute delay, instead of triggering the pipeline at 1:35 or 1:40 pm, it is triggered at 1:36 or 1:41 pm. For the exam, go through these differences between the schedule and the tumbling window trigger as shown in this table. Another capability of tumbling window triggers that the schedule trigger do not have is the retry capability. Per the requirement, we set the retry count as 3 and enable the trigger to rerun the pipeline in 30-second intervals. To intentionally fail the pipeline, I added a fail activity. After the pipeline is published, you can view that the pipeline runs are failing for the 840 to 845 window. After the 30-second interval, the trigger reruns the pipeline for the same tumbling window and it fails again as we have not removed the fail activity. In the next 30 seconds, the trigger attempts to rerun the pipeline for the same window. Since we set 3 retries, the trigger will attempt to rerun the pipeline one last time. Option C is the correct answer. You have two pipelines in Azure Data Factory as shown below. The 5-minute telemetry pipeline processes the telemetry data every 5 minutes. The 5-minute data process pipeline performs data analytics transformation every 5 minutes. How would you configure the offset and size of the dependent tumbling window trigger if the 5-minute data process pipeline should be processed only after the current and the immediate previous and the next window of the 5-minute telemetry pipeline is successfully run? By using tumbling window triggers, you can configure dependent pipelines. That is, you can ensure that a pipeline is triggered only after another pipeline runs successfully. Both the given pipelines are run by different tumbling window triggers every 5 minutes. To ensure the data process pipeline is dependent on the telemetry pipeline, navigate to the trigger that runs the data process pipeline and add a trigger dependency. To configure dependency on another tumbling window trigger, we specify two values in a timestamp format: offset and window size. Consider the offset as the starting point on the dependent window. A positive offset shifts the starting point to a future window, and a negative offset shifts the starting point to a past window. Since the starting point of the dependent window is in the past, we use a negative value for offset. So options C and D are incorrect. As the data process pipeline is dependent on only the immediate previous window, it is sufficient to offset the dependency to one previous window, which is 5 minutes. So we can eliminate option B too. Consider the window size as the duration of the dependent window. Since the pipeline depends on the previous, current, and next windows, setting the size as 15 minutes ensures the trigger will run only if those three windows are run successfully. Option A is the correct answer. Let's verify this using the Azure Data Factory Studio. In both pipelines, I added a wait activity to avoid errors as we cannot publish a pipeline without any activity. I already set up the triggers for both pipelines as just discussed. For each pipeline, I defined the two parameters pstart and pend. Further, I passed the system variables supported by the tumbling window trigger as parameter values while triggering the pipeline. After publishing the pipeline, go to the monitoring section. The easiest way to verify is to check the latest start and end window for the data process pipeline, which is from 1705 to 1710 UTC. Per our understanding, if the window between 1705 and 1710 for the data process pipeline is processed, then all the windows from 1700 to 1705, 1705 to 1710, and 1710 to 1715 of the telemetry pipeline should be run successfully. If you check the last three successful runs of the telemetry pipeline, you will observe that it is indeed the case. You author pipelines in Azure Data Factory. You have the below two requirements. Requirement 1 is author data flows to aggregate the data in Azure Data Lake storage and store it back in ADLS. Requirement 2 is copy the aggregated data from ADLS in the Japan East region to the Azure SQL database in the same region. Ensure the data does not move outside the Japan East region. Which integration runtime would you use for each requirement? Integration runtimes are the compute infrastructure used by Azure Data Factory. Azure Data Factory pipelines can be run with three types of integration runtimes. Azure Integration Runtime for cloud data stores, self-hosted integration runtime for on-premises data stores behind a firewall, and Azure SSIS integration runtime for lift and shift of SSIS packages to the cloud. You can use only the Azure integration runtime to author data flows. You can use either the default auto-resolve integration runtime, a type of Azure integration runtime that comes by default with each Data Factory instance, or create a dedicated Azure integration runtime for running data flows. So requirement 1 is Azure integration runtime. If you use the default auto-resolve integration runtime, Data Factory tries to select the integration runtime in the region of the sink's data store, which is Japan East. But if the IR is not available in Japan East, the Data Factory will choose an IR in the closest region in the same geography, which could be Japan West. By using the default IR, you may run into a problem where the data could move out of the Japan East region. To ensure the data always stays within the Japan East region, create a dedicated Azure integration runtime in the same region. To ensure the dedicated IR is used by the copy activity, it is sufficient to associate the regional IR with either the source or the sync linked service. Copy activity will use this dedicated IR as it will take precedence over the default globally available IR. So, requirement 2 is also Azure Integration Runtime. Option C is the correct answer. Other than the default auto resolve integration runtime, you have a dedicated Azure integration runtime and a self hosted integration runtime as shown below. You create a copy activity, activity 1 in pipeline 1, to move data from the on premises SQL Server to the Azure SQL database. Another copy activity, activity 2 in pipeline 2, moves the data vice versa. Select which integration runtime will be used to run each activity. Since the source in activity 1 and the sink in activity 2 is SQL Server, the linked services of the source dataset in activity 1 and the linked services of the sink dataset in activity 2 use the self-hosted IR. Since the sink in activity 1 and the source in activity 2 are Azure SQL database, the linked services of the sink dataset in activity 1 and the linked services of the source dataset in activity 2 can use either the dedicated Azure integration runtime or the default auto resolve integration runtime. But let's use the dedicated runtime for reasons you will understand in a while. Let's debug activity 1 that copies data from SQL Server to Azure SQL Database. The activity uses the self-hosted integration runtime. Let's also debug activity 2 that copies data from Azure SQL Database to SQL Server. This activity 2 uses the self-hosted integration runtime. So, if there is more than one type of integration runtime used in an activity, the self-hosted integration runtime takes precedence over the Azure integration runtime, and the Azure IR takes precedence over the default auto-resolve integration runtime. That's why we use the dedicated Azure IR rather than the default IR, since it has higher precedence. You can try running activities using the default IR and self-hosted IR and observe the results. Since a SQL Server is used either as a source or a sink in the two activities, we observe that the self-hosted IR is used for both the copy activities. This knowledge is especially important if you are looking to achieve high performance in a copy activity. As the self-hosted IR is always used for copying data between on-premises data stores and the cloud, to improve the copy performance, you should either scale out, which is adding more nodes to the self-hosted IR, or scale up, which is to allow more concurrent jobs in the self-hosted IR. Only scaling the Azure IR will not help. Option D is the correct answer. A data factory is connected to a Git repository using Azure Repos. A developer is creating a copy activity in a feature branch. Based on the given information, answer the below two questions. For the copy activity, let's create a linked service for the source dataset Azure Blob Storage. Select the authentication type and the storage account. Test the connection to the storage account to ensure it is successful, then create the linked service. Immediately, you get a message that Data Factory cannot store credentials in a Git repository. Since we are not storing the credentials in Azure Key Vault, the linked services will be published to the Data Factory service. As soon as the linked services are created, and even before the feature branch is saved, you can view the created linked services in the feature branch. As expected, in the Data Factory service too, you can view the linked services. But you cannot view them in the main branch of the Git repository. So question 1 is, after the linked services are created in the feature branch, refer to the standard architecture of the CI/CD lifecycle in an Azure Data Factory that's configured with Azure Repos Git. Per the architecture, you can publish to the Data Factory service from only the main or the collaboration branch and not from the feature branch. Understandably, the publish button is disabled on the feature branch. So when the developer clicks publish, he can do so from only the main branch. Question 2 is main. Option D is the correct answer. Although we get a message that the data factory cannot store the credentials in a Git repository, it means that the data factory will not store the credentials in plain text in the Git repository. If you check the feature branch, the encrypted credentials are still stored in the source control. That's why credentials are immediately published to the data factory service. If you use a key vault to store secrets, references to key vault will replace the encrypted credentials in this JSON. In that case, Data Factory reads from the key vault and there wouldn't be any need to publish to the service immediately. You configure a Git repository for your development environment of Data Factory with Azure Repos. A developer plans to create a new feature branch for adding an activity to the pipeline. How can he get his changes published to the dev environment? Refer to the standard architecture of the CI/CD lifecycle in an Azure Data Factory that's configured with Azure Repos Git. After setting up the repository, we have only the main branch or the collaboration branch from where we publish the changes to Data Factory service in the dev environment. But when developers need to update the Data Factory, they do not do so in the main branch. They create a new branch called the feature branch, which is based on the main branch. The feature branch contains all the updates available in the main branch. In this feature branch, they add an activity to the pipeline, debug, and save the branch. You can view this saved branch in Azure DevOps. In the Data Factory, you can see that the Publish button is disabled for the feature branch. That's because the changes in the feature branch have to be reviewed and then merged into the collaboration branch by creating a pull request before they can be published to the data factory service. So option A is incorrect. Let's create a pull request to merge the changes from the feature branch with the main branch. While completing the pull request, just ensure not to delete the feature branch as we still need it in the future. So creating a pull request from the feature branch to the main branch is the correct way to merge the changes. Option B is the correct answer. If you switch to the live mode where you can author directly against the data factory service, you see a message that publishing in the data factory mode is disabled. So once you enable Git, you can publish only via the Git repository. Option D is incorrect. Only after you begin to publish from the collaboration branch to the data factory service, Azure Data Factory creates the ADF underscore publish branch. When the publishing process is complete, the data factory generates the ARM templates of the published factory and saves them in this branch. From the ADF underscore publish branch, the ARM templates are used to deploy the pipeline in other data factory environments. So as you can imagine, the function of the ADF underscore publish branch comes much later during the publishing process. It makes no sense to create a pull request from the feature branch to the ADF underscore publish branch. Option C is incorrect. To a published Azure Data Factory pipeline, you add a lookup activity. When you try to publish the new changes to the Data Factory service, you get a publishing error as shown below. You plan to fix the error later, but in the meantime, you would like to save your work even if it has validation errors. Which of the following would you not do? Select two options. If the pipeline has validation errors, the Data Factory service will not allow you to publish the artifacts. As you drag and drop the factory resources onto the canvas, the JSON code and the ARM template gets updated, representing the current architecture. If you need to reference the pipeline with validation errors in the future, you can export this pipeline as an ARM template. In the ARM template, you can view the unpublished lookup activity. The developer can save this template and later update the data factory environment by importing this ARM template. Option B is incorrect. The developer can also view the JSON code representation of the pipeline, which is updated with the latest changes. He can copy and save the JSON in a local file. Later, when he resumes work, he can replace the published JSON with the copied JSON to view the unpublished changes. Option C is incorrect too. Note that we are authoring a pipeline directly against the Data Factory service. There is no option to create a service request to display a save button on the Data Factory authoring page. Option D is one of the correct answers. If you need the Data Factory to display a save button, Connect the data factory to a Git repository, in which case the Save button will allow you to save even the unpublished changes to a code base in a version control system. This sounds like a good solution, except for the fact that setting up a code repository requires no unpublished changes. This solution forces the user to discard the changes and will not allow him to continue the work from where he left off. Option A is the other correct answer. You create a diagnostic setting as shown below to send resource logs to the Log Analytics workspace for your Azure Data Factory resource. You plan to configure the Data Factory pipeline to run every minute. Which table would you query in the workspace to view the diagnostic logs? While configuring a diagnostic setting to send resource logs to the Log Analytics workspace for a resource, you can set the collection mode as either Azure Diagnostics or resource specific. If you choose Azure Diagnostics as the collection mode, all data is collected in the Azure Diagnostics table in the Log Analytics workspace. This table is not specific to the Data Factory resource, and many types of Azure services can send logs to this table. However, in the given question, the collection mode is set to resource specific and not Azure Diagnostics. So we can be sure that the resource logs are not collected in the Azure Diagnostics table. Option B is incorrect. To verify where the data is collected, let's create a schedule trigger that runs the pipeline every minute. In the Log Analytics workspace, you can view the tables related to Azure Data Factory by searching for ADF. ADF Activity Run, ADF Pipeline Run, and ADF Trigger Run are some of the tables where we can remotely guess that the log of pipeline run may be collected. As you can observe, we couldn't find the table ADF Schedule Run. So option D is incorrect. Let's query the table ADF Trigger Run. The query doesn't return any results. In the question, only the log of the pipeline runs are selected. Had the log of trigger runs been selected, the logs would flow to the ADF trigger run table. Just try verifying this with your Azure subscription. Option C is incorrect. Let's query the ADF pipeline run table. As expected, the log of pipeline runs flow only to this table. Option A is the correct answer. You have an Azure Data Factory pipeline that you want to run from today for the next 9 days. The pipeline should be triggered only at the following times each day. How would you configure the recurrence for the schedule trigger? Configuring every 60 minutes will trigger the pipeline every 60 minutes from the start date till the end date. Since the end date is 9 days from the current day, the pipeline will be triggered every 1 hour up to the end date, which is not required. Option A is incorrect. The behavior of configuring every 1 hour is similar to configuring every 60 minutes, as they both are equivalent recurrence schedules. Option B is incorrect too. As you move towards low granularity time values, the schedule trigger provides options to select high granularity time values. For example, as you move from hour to days, you will get the option to select high granularity time values like hours and minutes. Similarly, if you specify weeks, you will get the option to select high granularity time values like days of the week and the hour and minutes. So, if you configure every one day as a recurrence, you will get the option to select more granular details like hours and minutes. To run the pipeline at the specified times, set the hours to 5, 6, and 7 and set the minutes to 30. The pipeline will now run daily at the scheduled times 5:30, 6:30, and 7:30, which are the possible combinations of all values of the two fields, hours and minutes. Option C is the correct answer. Configuring every 3 days will not work as we need the pipeline to run every day up to the end date. Option D is incorrect. You have an Azure Data Lake Storage Gen 2 Premium account that has the below two data access requirements. If any data center fails, users should still be able to access the data. Optimize for low latency for both read and write. Ensure you minimize the cost for both the requirements. What action would you perform for each requirement? Data in the Azure Data Lake storage is always replicated to protect it from failures. If you choose LRS or locally redundant storage, the data is replicated 3 times within a single data center. LRS cannot be a solution because if the data center fails, users can no longer access the data. Choosing ZRS or zone redundant storage is a possible solution as the data is replicated 3 times in 3 different data centers, all belonging to a separate availability zone. So, if any data center in an availability zone fails, users will still have access to the other two data centers in different availability zones. GRS or geo-redundant storage is also a possible solution. The data is replicated 3 times in a single data center in the primary region before asynchronously copying it to a data center in the secondary region. If the data center in the primary region fails, users will still have access to the data center in the secondary region after the failover process. Since ZRS is cheaper than GRS, we should use ZRS for requirement 1. In a standard Azure Data Lake storage account, the blobs can be tiered to hot, cool, or archive tiers. But in a premium storage account, object tiering is not yet supported. So you cannot move the account from the premium to the hot access tier. Further, since the premium data lake storage accounts already provide very low latency for both read and write operations as compared to the standard storage accounts, the current setup is good enough to satisfy requirement 2 and no action is required. So, requirement 2 is no action required. Option A is the correct answer. In an Azure Data Lake Storage Gen 2 account, there are two empty directories, HR and IT, in a container. The employee data from the respective teams will be uploaded daily into these directories. There are two users, user 1 and user 2, with a reader role in the subscription scope, have the below access requirements. User 1 needs to read all uploaded files within those directories in the container. User 2 needs to read only the IT directory and files within it. What solution would you recommend for each user to access the data? Data lake storage has several authorization mechanisms such as RBAC, ABAC, ACLs, SAS signatures, and shared key authorization. Of these, we are concerned with only role based access control and access control list in this question. Given that both users already have a reader role in the subscription scope where the data lake storage is created. So both will have permission to view the data lake storage resource. Since the reader role has no permissions in the data action section, both user 1 and user 2 cannot view any directories in the data lake storage container. One possible solution to authorize access to data in the data lake storage is to assign RBAC roles, especially the ones that provide access to data. For example, the storage blob data reader role. Since this role has permissions that provide read access to containers and blobs in the data action section, the user assigned this role can read both the directories within the container. Since the lowest level that you can assign the RBAC role to allow access to data lake storage is at a container scope, assigning this role even at the lowest level means the user gets access to all directories and blobs within the container. As high granular data access is not required for user 1, assigning this RBAC role at any scope ensures the user can access both the directories within the container. Although the same output can be achieved with access control list, as you will see in a while, managing ACLs is more complex as it offers a high level of customization and specificity. So user 1 is role based access control roles. To provide high granular data access, or in other words, to provide access to specific objects like files and directories within the container, use access control list. So to enable user 2 to access only the files in the IT directory, first use access control list to assign read and execute permissions to the user on the container or the root directory. This ensures the user can traverse the root directory. Unless you assign default ACLs, these permissions are not inherited by the child directories. So again, assign access ACLs for user 2 only to the IT directory. So the user can click into this directory and list any files if available. Since these were empty directories, let's upload a sample file. As I said earlier, the access ACL permissions are not inherited by the child items. So, although user 2 can list items in the IT directory, he cannot read them. Refer to the question in practice test 2 with the related lecture video titled Default ACLs to read a file in Data Lake Storage Gen 2 to understand how default ACLs work. To ensure the user can read all new uploaded items, assign default ACLs to user 2 on the IT directory. Now, if any new file is uploaded in this directory, he can read that file. Further, as none of these permissions are assigned to the user on the HR directory, user 2 will not be able to access that directory. Since we assign ACLs at different levels to provide more granular and specific access to data, managing them is more complex than managing RBAC roles. So, user 2 is access control list. Option D is the correct answer. You have an Azure Data Lake Storage Gen 2 account. In this account, there is a hierarchy of resources such as a container and a single file 01.csv as shown below. You, the admin, assign access ACLs and default ACLs for the container to the user 1 as shown below. Later, someone on your team uploads a second file 02.csv to the same container. Which of the following CSV files can user 1 read who is already assigned a reader RBAC role in the subscription scope? Refer to the question in practice test 1 with the related lecture video titled Assign ACL permissions to modify a file in Data Lake Storage Gen 2 to understand the order of evaluation of permissions for access to data in Azure Data Lake Storage. There are two types of access control list: access ACLs and default ACLs. Using access ACLs, you define access control for a specific file or a directory. For example, in the given scenario, user 1 has read and execute permissions on the container. Default ACLs define permissions that are automatically applied to all new files and directories created inside this container. For example, user 1 will have read permissions to any new file or directory created in this container. Given that user 1 is assigned a reader role in the subscription scope, so he can view all resources in the subscription. Although the reader role does not have any permissions in the data action section, he can still view both the files in the data lake storage container, as we had assigned both read and execute permissions using access ACLs. Remember from the question that only 01.csv file was originally uploaded and 02.csv file is uploaded after the default ACLs are set up. The default ACLs take effect on only the new items created in the container and not on the existing items. You can confirm this by checking the ACLs for 01.csv file. Since the default ACLs on the container for user 1 are set up after 01.csv is uploaded, user 1 will not have any ACLs for this file. Since 02.csv file is uploaded after the default ACLs are set up, user 1 will inherit default permissions from the parent. So, due to how these default ACLs work, user 1 will not be able to access 01.csv. However, he can access 02.csv file. Option C is the correct answer. You have an Azure Data Lake Storage Gen 2 account. In this account, there is an hierarchy of resources such as container, directory, and file as shown below. A user 1, who is assigned the reader role at the subscription scope, needs to update the CSV file using Azure Portal. How would you configure the access control list for the user at each level of the hierarchy? Assign only the least permissions required to do the task. Before answering this question, it is important to understand how permissions are evaluated for access to data in Azure Data Lake Storage. First, the system evaluates Azure role assignments for the user. If the assignment grants sufficient access to data, the ACLs are ignored. Only if the user doesn't have enough access permissions, the ACLs are evaluated. Given that user 1 is assigned a reader role in the subscription scope, so he can view all resources in the subscription. Since the reader role does not have any permissions in the data action section, he cannot view the directory and the file in the data lake storage container. The ACL permissions on directories and files in a container can be read, write, and execute. To traverse the directory, we need execute permission. However, assigning only the execute permission to the user will not grant permission to list the contents of a directory. So we will still see the same error as seen earlier. To list the contents of a directory, we need both read and execute permissions on the directory. After these two permissions are assigned, user 1 can read the contents of the container, which is just a single directory. Anyway, the question does not ask what permissions are required on the root folder or the container. So let's proceed to analyze the permissions required for the directory. Since the reader role doesn't grant access to data, and since we have not assigned any ACLs to the user on the directory, he will get an error when he clicks the directory folder. As you might guess, to navigate to the directory, you would need to assign both the read and the execute permission to the user at the directory level. Doing so would allow him to view the file in the directory. However, the user still will not be able to edit the file. As you can see in this table, the write permission on the file is not required to either delete or update the file. To allow these operations on the file, ensure that the file's parent directory has the right permission. So let's go back to the parent directory and add right permission to the user. The reason why I removed the mask is beyond the scope of this video, but you can understand its functionality from the Microsoft Learn website. Now, user 1 should be able to update the file. So you don't require any permission on the file, but need RWX permission on the parent directory. Option B is the correct answer. The studentmarks.csv file is in the Azure storage account. It contains 8 records of the marks obtained by students in different courses. In an Azure Data Factory pipeline, you execute a data flow that reads data from the source CSV file. The data flow contains an aggregate transformation with the following settings. Based on the given information, answer the below two questions. How many rows and columns will be inserted into the sink? The given data has 8 records, 1 for student ID 1, 2 for student IDs 2 and 3, and 3 for student ID 4. In the aggregate transformation for the mapping data flow, we specify two inputs for aggregating data: the column to group by, which is the student ID, and the aggregates. The aggregate transformation works exactly like the group by clause in SQL. For a moment, let's delete the given column pattern for the aggregate. Similar to SQL, to make this a valid query, we need to include all columns used in the group by clause in the select clause. Here it is the aggregates tab with an aggregate function like the max applied to it. We should expect a row for each unique value of the student ID. Since there are 4 unique students, we should see 4 records. A similar scenario plays out with the given question. The group by clause produces distinct records of the field or a combination of fields used. Since there are 4 student ID records, the group by will produce 4 rows. So rows is 4. So this group by field, student ID, is one of the output columns. The rest of the columns in the output come from the aggregates. In the aggregate section, we create a column for every column whose name does not match the student ID. That is, we get all the columns from the source except the student ID column. The $$ references the input name of a matched column. If you inspect the columns, you will realize that there is one group by column and 3 aggregate columns. So there will be a total of 4 columns. Columns is 4. Option D is the correct answer. If you are curious about the result set, then continue watching. Since we use the last function on the input columns, we will get the last record for every result set. That is, if there is a duplicate student ID, we will get only the last record for that student ID. So for student ID 4, we will get only the details of his enrollment in course C03. You have a students.json file that contains student objects in your Azure storage account. Each student can enroll in multiple courses as shown below. The JSON file is updated daily, and the data factory pipeline that reads this file is scheduled to trigger in the same cadence. You have two requirements. For every combination of the student and his enrolled course, store them as an individual row in the Azure SQL database. New student records in the file must be inserted into the database, and changes, if any, on the existing objects must be updated. Which two data flow transformations would you use? Let's add a source that reads the data from the JSON file in the data flow. You can observe that the data flow detects the course ID as an integer array and the contact field as a complex object that has two properties, phone and email. Since the given file contains array values for course ID inside the hierarchical JSON structure, we need to use the flatten transformation to unroll the course ID array into individual rows. Okay, this error is because since the source contains the JSON in array format, we need to select array of documents for the document form field. In the data preview section, you would observe that the flatten transformation flattens the array values inside the JSON into individual rows, creating multiple records for each student to account for his different enrolled courses. Now you can connect a SQL sync to the flatten transformation to insert rows into the Azure SQL database. Just ensure to check if the fields are correctly mapped. The plus sign indicates that all rows will be inserted into the SQL table. Publish the pipeline that runs this data flow and manually trigger the pipeline. Once the pipeline run completes, you can view that for every combination of the student and his enrolled course, the flattened transformation stores them as individual rows in the Azure SQL database. Option A is one of the correct answers. If you feel overwhelmed about the data flows shown here, please do not be. I try to make it very easy for you by sharing the associated files. Just download the lab files associated with this question or any other question and follow all the given instructions to replicate the same environment. You can see and play with all the configuration options, which will make your learning even better. Now, for the second requirement, let's add a new student object with student ID 3 to the JSON file and update the phone for student ID 2. The student ID 1 is untouched. If the JSON file changes, we need to either add new student records to the SQL table or update the rows for existing students. So, insert an alter row transformation between the flatten transformation and the sync with an upsert condition which either updates or inserts rows. If you publish the changes and reload the page, you can view the rows that will be added or updated in the data preview section. Note that the condition true marks all rows with the upsert policy. By default, only insert operations are allowed on the sync data store. Since we will be either updating or inserting the records into the table, allow upsert on the SQL database and select SID, which is the student ID, as a key column to determine if a row from the source matches a row from the sync. So every student ID from the source is compared with the SID in the sync. If there is a match, the sync record will be updated with the source record, else the new record will be inserted. Let's trigger the pipeline that runs this data flow and confirm if we indeed see those changes in the sync SQL database. Remember that we already have 4 existing records in the sync. After the pipeline run completes, we will have 2 new records and the phone of student ID 2 updated. Option D is the other correct answer. Parse transformation is used to extract specific information from text data based on formats like JSON or XML into a structured format. The flatten transformation is ideal for flattening complex nested structures like arrays or objects into individual rows. Option C is incorrect. We can do an upsert only within an alter row transformation. There is no separate upsert transformation available. Option B is incorrect. This is the third question in the question set. The problem is the same, but it has a different solution, which is to add a single conditional split transformation for both the requirements between the source and the sink with the disjoint value set as true. Does the solution meet the stated goal? The disjoint value set to true means that the split occurs on all matching conditions rather than just the first matching condition. Similar to what we observed in the previous question, every row with region equal to central goes to the output stream central region. But unlike in the previous question, all rows are available for split on the second condition. So all rows with the condition segment equal to home office go to the second output stream home office segment. This solution satisfies both the first and the second requirement, where the central region stream contains records from only the central region and the home office segment stream contains records from only the home office segment. To verify this, let's trigger the pipeline that runs this data flow. After verifying with the source file, we can confirm that all records from the central region flow to the sync table dbo.central. But since the split happens on all the matching conditions, all the matching rows that satisfy the condition segment equal to home office flow to the sync table dbo.homeoffice. The given solution meets the stated goal. Option yes is the correct answer. This is the second question in the question set. The problem is the same, but it has a different solution, which is to add a single conditional split transformation for both the requirements between the source and the sink with the disjoint value set as false. Does the solution meet the stated goal? Let's add a conditional split transformation with two conditions: region equal to central and segment equal to home office. The disjoint value set to false means that the split occurs on the first matching condition rather than all matching conditions. So first, every row with region equal to central goes to the output stream central region. All remaining rows matching the second condition segment equal to home office go to the second output stream home office segment. So although this solution satisfies the first requirement, where the central region output stream contains records from only the central region, the second requirement is not satisfied as only the remaining rows with the matching condition go to the home office segment stream. To verify this, let's connect another sink to the home office segment stream and direct the output to the Azure SQL table dbo.homeoffice. When we publish the pipeline that runs this data flow and trigger the pipeline, we should see the data flow to two Azure SQL database tables. After verifying with the source file, we can confirm that all records from the central region flow to the sync table dbo.central. But since this split doesn't happen on all the matching conditions, only the remaining rows flow to the sync table dbo.homeoffice. Consequently, fewer rows flow to the sync table than expected. The given solution does not meet this stated goal. Option no is the correct answer. This question is part of repeated scenario questions that contain the same stem but with a different solution for each question. You need to identify if the given solution solves a particular problem. Each set of repeated scenario questions might contain either none, one, or many solutions. You have sales data in a CSV file in your Azure storage account. You need to use this data as a source to create a data flow in Data Factory that stores all records from only the central region in a sync table named Central in Azure SQL database and stores all records only in the Home Office segment in a sync table named Home Office in Azure SQL database. The two sync tables have the same schema as shown above. The solution is you add two conditional split transformations, one for each requirement, between the source and the sink. Does the solution meet the stated goal? You can use data flows to visually design data transformations in Azure Data Factory. For example, instead of using scripting language to write transformations or aggregations, you can use data flows to just drag and drop and visually create those transformations. Coming to the question, we need to store all records from the central region in one sync table and all records from the home office segment in another sync table. So some sales transactions from both the central region and the home office segment must be stored in both sync tables. To implement the solution given in this question, let's add a conditional split transformation named central region, where I will create a split based on the condition region is equal to central. Turn on the data flow debug mode to debug and watch how the data is transformed before publishing your work. After the debug mode is turned on, navigate to the data preview section to view the data produced by the split transformation, which are only the records of the central region. Per the solution, let's add another conditional split transformation named home office segment, where I will create another split based on the condition segment is equal to home office. If you check the data preview section, the final output will be the result of two applied filters. Region is equal to central and segment is equal to home office. But per the requirement, we need to apply filters separately and store all rows with region is equal to central in one Azure SQL table and store all rows with segment is equal to home office in another Azure SQL table. So the given solution does not meet the stated goal. Option B is the correct answer. You have an Azure Key Vault created with the Azure RBAC permission model. In other words, you grant access to data like keys and certificates using Azure RBAC roles. You are assigned the owner role in the subscription. You want to use your keys in the Key Vault to encrypt the below data factory, which has a single pipeline. Which two actions would you perform? As shown in the question, Azure Key Vault offers two types of authorization systems: Azure RBAC, which operates on Azure's control and data planes, and the access policy model, which operates on only the data plane. The control plane allows us to manage Azure resources, for example, creating a key vault. The data plane allows us to use capabilities exposed by the Azure resources. For example, accessing the secrets and keys in the Key Vault. Although you are assigned the owner role in the subscription, the role allows you to perform only the control plane operations. Data plane operations like listing the data in the Key Vault will not be allowed, as the owner role does not have permissions listed under the data actions section in its role definition. So to enable us to list and create keys in the Azure portal, let's self-assign a role that allows data plane operations on the Key Vault, for example, the Key Vault administrator role. To use our own keys to encrypt the data factory, let's create a key in the Key Vault and copy the URL to the key. In addition to the default Microsoft managed key that encrypts the data factory, to use the customer managed key for encrypting the data factory data, paste the copied key URL in data factory. You get the error message that the data factory must be empty if you need to add a customer managed key. So we need to delete the pipeline before adding a customer managed key. Option B is one of the correct answers. After deleting the pipeline, we try again to add the URL to the key in the Key Vault. We get the error message that access is forbidden by RBAC. That's because the data factory doesn't have access to the Key Vault. To enable access via RBAC, assign a role that allows data plane operations on a key vault to the managed identity of the data factory. Now, when you add the key URL in data factory, it should work without any issues. So the second action would be to grant permission for the data factory to access the key vault. Option C is the other correct answer. Note that the data factory requires permission to access the key vault, so we need to assign a role to the data factory and not the key vault. Option D is incorrect. The given key vault has the RBAC permission model, which Microsoft recommends. There is no need to change the permission model of the key vault to access policy. Option A is incorrect. If you assign a RBAC role that has permissions to perform data plane operations on a key vault, for example, the key vault administrator role, the role will have the necessary data plane permissions like wrap or unwrap key permissions in the data actions section. Only if you choose the access policy permission model for the key vault, you would be required to individually assign get, wrap and unwrap key permissions. Option E is incorrect. You have the below data factory pipeline as shown. Set variable 1 and set variable 2 activities run on success and completion of the fail activity respectively. Assume all set variable activities always succeed. Based on the given information, answer the below two questions. Recall from practice test 1 with the related lecture video titled Evaluate Pipeline Status in Data Factory that Data Factory marks a pipeline run as succeeded only if the leaf activities of all paths or their parent activity, if the leaf activity is skipped, are successful. A fail activity simulates a failure by intentionally throwing an error. When you debug the pipeline, the first activity fails, so the set variable 1 activity will be skipped as it will be executed only if the status of the previous activity is successful. But the set variable 2 activity will run as the previous activity, although failed, is still completed. Since the set variable activities always succeed, the set variable 2 activity will be successful. However, the overall pipeline will still fail as the status for the parent of the skipped set variable 1 activity is failed. So, question 1 is failed. The design of this pipeline means the set variable 2 activity will always run and the set variable 1 activity will always be skipped. So the presence of set variable 1 activity means this pipeline will always fail. To mask the failure of the parent activity, you can add another set variable activity that runs upon skipping the set variable 1 activity. As set variable 1 activity is always skipped, the new set variable activity always runs, producing a successful result in the other leaf. As both the leaves return success status, the status of the pipeline will be successful. So, question 2 is upon skipping set variable 1 activity. Option C is the correct answer. If you configure a new set variable activity upon failure of fail 1 activity, both the new set variable 3 activity and the set variable 2 activity will run and succeed. Since this does not mask the failure of the parent activity of set variable 1 activity, the pipeline will still fail. But do note that in the documentation, Microsoft claims that for each pipeline run, at most one path is activated based on the outcome of the activity. This means upon completion path cannot coexist with either upon success or upon failure path. As you can see here, in Data Factory, we observe contradictory results where both the failure and the completion path are executed in a pipeline run. I have created a ticket with Microsoft which you can find here. You connect Purview account to a data factory which has pipelines that transform data in a storage account. From where can you discover organizational data sets registered and scanned by Microsoft Purview based on keywords? After you connect the Purview account to Data Factory and execute a pipeline, you can discover the organizational datasets from Microsoft Purview using the search bar. Rather than discovering the datasets in Purview, you can also search them in Data Factory itself using the search bar. While searching, just ensure to select Purview to discover your organization data. Using these assets, you can directly create linked services or datasets for your Data Factory pipelines. There was some issue with the Purview account, so I was not able to search for the assets from Data Factory. In case you observe a similar issue, check the issue raised with Microsoft, which may offer some solutions. Option B is the correct answer. In Azure Storage Explorer, you can view all the available data in a storage account. There is no way to discover only the datasets registered by Microsoft Purview. Option D is incorrect. Your data factory connected to Microsoft Purview has two pipelines. The pipeline 1 copies data from one storage account container to another. The pipeline 2 executes a script activity that runs a query on the Azure SQL database. Based on the given information, answer the following questions. Microsoft Purview helps organizations manage, protect, and govern their data across different environments. Connecting Data Factory to Microsoft Purview allows you to capture and view the lineage data from Data Factory in your Purview account. Once you connect the Data Factory to a Purview account, execute the pipeline. During the pipeline run, Data Factory pushes the lineage information to Microsoft Purview. In case a pipeline is updated to, executing the pipeline will push the updated lineage information to Purview. You can view the lineage data by navigating to Microsoft Purview. You can also verify if the Data Factory reported the lineage data to Purview in the pipeline output. You don't need any additional configuration for lineage data capture. So, question 1 is run the pipeline. Currently, reporting data lineage is supported only for copy, data flow, and execute SSIS activities. Since pipeline 2 runs only a script task, you wouldn't be able to see any lineage information in the pipeline output. So, question 2 is only pipeline 1. Option B is the correct answer. Given below is the failed run of a data factory pipeline. After fixing the web activity, you run the pipeline again with the below result. Based on the given information, answer the below two questions. To intentionally fail the web activity, I use the get REST API method to retrieve a dummy URL from my website and set the maximum number of retry attempts in case the activity fails to 1. Once the pipeline is triggered, we can expect the web activity to fail. Since we set the retry attempt for the web activity to 1, the failed activity will be retried one last time. Since the activity will fail again, the pipeline status will be failed. So if you set the retry attempt to 1 and if the activity is failing, we will have two total runs of the web activity, one original run and one retried attempt. Question 1 is 1. Let's fix the failed web activity by updating the URL to point to the DP-203 resource from my website. Now you can either manually trigger the pipeline or just rerun the pipeline from only the failed activity, in which case the activities prior to the failed activity, in this case the set variable activity, will be skipped. This is the reason why the status of the set variable activity in the second pipeline run is skipped. The answer pipeline dependencies is incorrect as the activity was not skipped during the initial run. Furthermore, it is the first activity in the pipeline and there aren't any activities that the set variable activity depends on. So question 2 is as it is rerun from a failed activity. Option D is the correct answer. Shown below is a pipeline 2 in your data factory environment. This pipeline contains a wait activity that waits for 5 seconds before throwing an error. The pipeline 2 is invoked from another pipeline 1, as shown below. Note the wait on completion property for the execute pipeline activity in pipeline 1 is not enabled. Based on the given information, answer the below two statements. Select yes if the statement is correct, else select no. If the wait on completion property is not selected for the execute pipeline activity that executes pipeline 2, pipeline 1 will not wait for the success or failure outcome from pipeline 2. As soon as the activity invokes another pipeline, the status of the execute pipeline activity is marked as successful and the pipeline will succeed. This despite the fact that pipeline 2 has failed. So statement 1 is no. If the wait on completion property is enabled for the execute pipeline activity that executes pipeline 2, pipeline 1 will wait for the success or failure outcome from pipeline 2. As you can guess, pipeline 2 waits for 5 seconds and then throws an error, causing pipeline 2 to fail. Consequently, the execute pipeline activity that invoked the pipeline also fails. The final result is the pipeline that invoked pipeline 2 also fails. So statement 2 is yes. Option A is the correct answer. Your Azure Data Factory environment has two pipelines, Pipeline 1 and Pipeline 2. In Pipeline 1, we use a set variable activity upon the success of the first activity. In Pipeline 2, we use a set variable activity upon failure of the first activity. Assume the set variable activity always succeeds. What will be the pipeline status after each pipeline runs? Azure Data Factory allows conditional logic to enable the user to take four different paths based on the outcome of a previous activity. They are upon success, upon failure, upon completion, and upon skip. To determine if a pipeline fails or succeeds, Data Factory evaluates the outcome for the leaf activity. If the leaf activity was skipped, it evaluates the status of its parent activity. Pipeline status will be successful only if the leaf activity or its parent of all different parts are successful. However, in both pipeline 1 and pipeline 2, we have only one path. So, to determine if the pipeline fails or succeeds, it is sufficient to check the status of the leaf or its parent activity. A fail activity simulates a failure by intentionally throwing an error in the pipeline. When you debug the pipeline, the first activity fails, but the set variable activity will be skipped as it will be executed only if the status of the previous activity is successful. Since in this case, the leaf activity is skipped, the data factory evaluates the status of its parent activity. As the status of the parent activity is a failure, the pipeline status will be failed. In pipeline 2, the set variable activity is run only if the previous activity fails. Since the previous activity intentionally fails, the set variable activity will be executed. As the set variable activity always succeeds, the pipeline status will be a success. So pipeline 1 fails and pipeline 2 succeeds. Option D is the correct answer.